So in this video, we're going to be looking at solutions to linear equations and how that applies to slope. So a good place to begin is really looking at patterns in our solutions to a linear equation. So let's take, for example, suppose that we wanted x to be -5, and we don't know what the y value is going to be, but this is going to be for an equation 2x minus 3y is equal to 5. Well, just to recall how we generate a solution, we plug the value in for x. So we've got 2 times -5 minus 3y is equal to 5. Well, 2 times -5 gives us -10. So we've got a -10 minus 3y is equal to 5. We add 10 onto both sides, which is going to give us a minus 3y is equal to 15. Now we'll just divide both sides by -3, and so we end up with y is equal to -5, and our corresponding solution of -5, -5. So if we look for other solutions to this particular equation, then we can have points, -2, -3, 1, -1, 4, 1, and 7, 3. Now we can go through each one of those as we kind of go through here, plug it in to make sure that each one of those does give us an actual true value. And sure enough, each one of those 4 points gives us a solution to the equation. Now, when we talk about patterns in those solutions, if we kind of do something called a T-table, and so we look at the x value and the y value for points along those solutions, if we look at the x values, we go from -5, -2, 1, 4, and 7. Now, kind of a common pattern between each one of those is that we can go from -5 to -2 by adding 3. -2 plus 3 gives us 1. 1 plus 3 gives us 4, and 4 plus 3 gives us 7. Now likewise, on the other side of that table, if we look at the y values for those solutions, we've got -5, -3, -1, 1, and 3. Common pattern with those, we've got -5 plus 2 gives us a -3. -3 plus 2 gives us a -1. A -1 plus 2 gives us a 1. And a 1 plus 2 is going to give us a 3. And so one thing that we can ask is, does this pattern actually continue to let us make new solutions, or was this just some kind of coincidence? And so let's see if we can generate a new point. And a new point, we're going to say something like, well, our pattern was we were adding 3 to the x value. So anytime we're talking about a change in a variable, this little triangle in front is called a delta. And so that's usually how we denote a change in a variable in mathematics. So you would actually say this as delta x, or the change in x is going to be 3. And likewise, the change in y in the pattern that we just observed was going to be plus 2. So if we take the last point that we had, our point 7, 3, and we add on the change in x to the x value, so 7 plus 3, we add on the change in y to the y value, so that's going to give us 3 plus 2 gives us a new point, 10, 5. And so the question really is 10, 5 a solution to our equation? Well, how do we go about checking that? We just plug it in and confirm it. So if we go 2x minus 3y is equal to 5, if x is 10, y is going to be 5, 2 times 10 gives us 20, 3 times 5 gives us 15, 20 minus 15, sure enough we have 5 is equal to 5. And so yes, this way of generating a new point with the pattern that we observe from the other points actually does work to give us new solutions. And so we could also say, well, what if we went backwards? So kind of going back to our table, if we started, instead of at the top, we started at the bottom. On the x value, 7 minus 3 gives us 4, 4 minus 3 gives us 1, 1 minus 3 gives us -2, -2 minus 3 gives us -5. Likewise, on the y values, 3 minus 2 gives us 1. 1 minus 2 gives us negative 1. Negative 1 minus 2 gives us negative 3. Negative 3 minus 2 gives us negative 5. And so let's generate a new point with the value delta x being negative 3. So our change in x is negative 3, and our change in y is going to be negative 2. So starting from our point, negative 5, we subtract 3 from our x value. So we've got negative 5 minus 3, which is going to give us a negative 8. We subtract 2 from the y value, so negative 5 minus 2 gives us negative 7. And just as before, we ask ourselves the question, is negative 8, negative 7 a solution to this equation? Well, once again, how do we check that? We just plug it in. So 2x minus 3y is 5. X is going to be negative 8. Y is going to be negative 7. 2 times negative 8 gives us a negative 16. 3 times negative 7 gives us a negative 21. So negative 16 minus a negative 21 gives us negative 16 plus 21, and that, sure enough, is 5. So that's a true statement, and again, we have generated a new solution. And so if we kind of want to see, well, does this work kind of arbitrarily? Well, we can just pick an x value. So if we make x2, for instance, we plug that 2 in and solve for y to generate a solution. So 2 times 2 gives us 4, minus 3y is equal to 5. We subtract 4 onto both sides, which gives us negative 3y is equal to 1. Divide both sides by negative 3, and we get y is negative 1/3. So our ordered pair solution is going to be 2, negative 1/3. Now, when it comes down to slope, what is slope exactly? Slope is combining these observations into one number. We're seeing this change in x, change in y, kind of generating new solutions. And so how do we put those things together into maybe one number that might be useful? Well, that's what slope is. So if we define slope as being our change in y over change in x, then if we say that that's going to be a plus 2 over plus 3, that gives us a fraction 2/3. But also, remember, if we went backwards, our changes were negative. If we had a negative 2 over negative 3, that still gives us a value of 2/3. Well, what if we take any fraction that happens to be equal to 2/3? Well, if we take 8/12, which does simplify to 2/3, and we make that our change in y over change in x, then we can say if our change in y is 8 and our change in x is 12, then starting with our last 0.73, we do 7 plus 12, that was our change in x, to give us a new x value of 19. We take 3 plus our change in y, which was 8. 3 plus 8 gives us a new y value of 11. So is 1911 a new solution? Well, let's take it and plug it in. 2x minus 3y is 5. 2 times 19 minus 3 times 11 is going to be equal to 5. Well, 2 times 19 gives us 38. 3 times 11 gives us 33. 38 minus 33 gives us 5 is equal to 5. And sure enough, yes, it is a solution. And so if we take any fraction that happens to be equal to our slope, that will also give us new solutions. And so if we just take kind of our arbitrary point that we had, our point 2, negative 1/3, then we can calculate the slope between that point and any other point, any other solution that we've actually generated already, and kind of compare the slope values. So if we say that our change in y is going to be the ending y minus the beginning y, the change in x is the ending x value minus the beginning x value, and if we take our beginning points as being the ordered pairs that we've already generated. So we've got -5, -5, -2, -3, 1, -1, 4, 1, and 7, 3. Our ending points being 2, -1/3 for each one of those. If we calculate our change in x's, so if we had the ending x value is 2, beginning x value is -5, 2 minus a -5 gives us a change in x of 7. Our change in y, we've got a -1/3 minus a -5, which gives us a 14/3. And we kind of continue this process for each one of those points. So our change in x values, we've got 7, 4, 1, -2, and -5. For our change in y values, we've got 14/3, 8/3, 2/3, -4/3, and -10/3. Now, if you're kind of watching this, I would invite you to go through and copy those, reproduce those calculations for yourself and actually convince yourself that, yes, that really does work. And then if I take my slope as being my change in y over my change in x, I've got a 14/3 over 7, which actually simplifies to 2/3. 8/3 divided by 4, which simplifies to 2/3. 2/3 over 1, which simplifies to 2/3. -4/3 divided by -2, which again is 2/3. -10/3 divided by -5 also gives us 2/3. And so we can see that the slope between any of the points any of the solutions we already have and the solution that we generated always gives us a slope of 2/3. And so what does that really give us as far as this relationship between the solutions of the equation, linear equations, and our slope? Well, the punchline is this. The slope is something called a mathematical invariant for the solutions to the linear equations. Now, what that really means is that the slope between any two solutions of a linear equation will always be the same. That's what we kind of looked at here. That was popping up when we compared the slopes between any of the 2 points that we had. So that's one side. The slope between any two solutions is going to be the same. But the flip side of that coin is if we take a new point that's generated from a solution to the linear equation and using the slope for the equation, that will also generate a new solution to the equation. And so kind of this duality that we have here, the two equations or two solutions always give us the same slope. A point and a slope generating new points will always be solutions to these linear equations. And so kind of why is slope important when we're talking about linear equations? That's why we've got this big connection between the solutions and the slope between those solutions and using the slope to generate new solutions. And so that's why it ends up being a big deal. So I hope you've enjoyed this. I hope it's kind of been a little bit eye-opening as to seeing what these new connections are. And so I hope to see you all next time.